Hello folks, today I'll talk about the comparative study of color edge detection techniques in computer vision. The basic aim of this project was to study color edge detection techniques, especially the vector order statistics edge detectors, and do a subjective and objective quality comparison with grayscale edge detection. Among various classes of color edge detectors, we use the vector order statistics edge detectors because of its computational efficiency and performance. For the grayscale edge detection, we use the Canny's edge detector, which is the most optimal and widely used edge detector for grayscale images. For objective comparison, we use the ground truth data of real edges from the Berkeley segmentation data set and did a objective analysis among different edge detection techniques. In the implementation of Canny's edge detector, the monochrome version of the color image is first smoothed out by a Gaussian filter to remove noise. We then calculate the gradient magnitude and direction by applying first derivative of the Gaussian filter. Then the non-maxima separation on the gradient magnitude is done using the gradient direction of the neighboring pixels, and finally we perform the min-max thresholding on the remaining pixels to identify the strong edges. The basic idea in vector order statistics class of color edge detectors is to construct a linear combination of ordered vector samples. In this class, the simplest one is the vector range edge detector, which expresses the deviation of the vector outlier in the highest rank from the vector median in the window W. If we assign certain weight to these coefficients and then sum it and then calculate the norm of the sum, then we get the vector dispersion edge detector. And finally, we have a variant of the vector dispersion edge detector called the minimum vector dispersion edge detector, which averages out the lower vector samples to improve performance. There is another technique in vector dispersion edge detector called the adaptive nearest neighbor, which takes into consideration the pixel values in the given window, and depending on the statistics of the pixel values, the weights to the coefficients are derived. In this slide, we see the results of the color edge detectors on the BSDS image. Clearly, it is evident that the Canny's edge output has missed out certain edges in this color while detecting edges from the color image, whereas VR edge output and MVD edge output have detected most of the edges. We also applied the same edge detection to a synthetic image. The synthetic image was formed by scrambling different type of color palettes on a color background, and then we applied the different edge detection algorithms. Clearly we see that the Canny edge detector output has missed out some of the color edges, whereas VR edge output and MVD edge output has actually detected most of the edges. The MVD edge output was successful in detecting edges that had very small color variations also. We also studied the impact of color edge detection under impulsive noise condition. So in this experiment, one of the BSDS images was corrupted with impulsive noise, and then we applied different edge detection algorithms on the corrupted image. Clearly we see that the Canny edge output had some kind of noise pixels, spurious noise pixels detected. VR edge output was very bad in performance, especially in noise conditions, but MVD edge output was able to actually filter out most of the noise pixels and still able to detect real edges. In the objective quality assessment, we take certain statistical parameters by comparing the edge output with the ground truth data, and then derive the metrics by which we can compare the different edge detection outputs. So we particularly used true positives, false negatives, false positives, precision, recall, and Pratt's figure of merit as the statistical parameters to compare the edge detection output. Pratt's figure of merit is particularly important because of the fact that it not only takes into consideration the actual pixels that have been identified as edges, but also ensures takes into consideration the spatial deviation of the detected edge pixels from the ground truth data. Finally, for objective quality assessment with impulsive noise, we want to plot the figure of merit versus the PSNR graph at various levels of noise corruption to see the performance of different edge detectors. Thank you for watching this presentation. For any questions, please email me or post your questions on the Piazza forum. Thank you.